Hello, everybody. Good morning, good afternoon, and good evening to everybody, and welcome to our annual webinar on the Global Mycotoxin Data Review. Before we start the webinar today, let me introduce myself and our speaker, Dr. Swami Haladi. Dr. Swami, hello. If you could please move one slide. Yes, thank you. So here you see a picture of me, and you also see me here on the camera. I am your host for today. My name is Marcella. And I will be helping Dr. Swami with running some polls with you and answering your questions. And about the questions, you can actually raise questions throughout the whole webinar by typing your questions into the menu of the GoToWebinar menu. And we will try to answer them after each section. And also at the end of the webinar, we will have a moment where we will answer as many questions as possible. We do have 3 polls lined up for you where we will need your input, so please stay tuned for those. And of course, as usual, we are recording this webinar and we will be sharing this recording with you afterwards. So let's move on to start today's webinar. Let me quickly introduce our speaker for today, Dr. Swami. Swami is Trout Nutrition's Global Program Manager for the Mycotoxin Risk Management Program. He obtained his bachelor and master's degrees in veterinary science in India, and then moved to Canada to obtain his PhD in animal poultry science. During his studies and career, he gained a lot of knowledge and interest in the area of mycotoxins. And he actually also published various articles in peer-reviewed journals as well as industry magazines, and he really understands the global challenge of mycotoxins. He actually developed practical limits as well for mycotoxins in various species. So it's really great that he will be sharing some of this knowledge and also some of this data that we have gathered with you today. So welcome, Dr. Haladi. I will hand over the control to you, and please feel free to start whenever you're ready.
Thank you, Marcel, and again a warm welcome to all the attendees today. And as you all know, for the 3rd year, we are running this webinar, pretty much around in the month of February, to give an overview of what the contamination of mycotoxins looks like in the previous year, but also just to give a little bit more idea to the 2022 challenges. Of course, whatever we grow in 2021, we use that in 2022 also, depending on the harvest, and that can vary from country to country, region to region, but definitely I'll touch upon that also. So before that, I will give a little bit of introduction to our Trout Nutrition's Mycotoxin Risk Management Program. Of course, a lot of data set is there, so we'll give a description of data. Then I go by the whole data analysis. That means, we don't categorize as raw materials or feeds or byproducts. So the initial discussion will be on the entire data set, as we gathered across the world. So then we go to the raw material analysis, because that is important for quality control programs at the feed mills, at the time of purchasing the raw materials. So that becomes a very important segment to look at. Just giving an example of maize there, a bit more detailed analysis. Then we go to the complete feed analysis, because as we are an animal nutrition company, animal industry, the impact of these mycotoxins on the performance of animals is the ultimate challenge to us. Whereas in a grain company is a different story. They are more interested in what is the level of mycotoxins before they sell the raw material. So that's why you see I give more emphasis on the complete feed analysis. What is the impact on animals? What does it really mean to the health and performance of animals? The number 6 point is about species risk assessment, because every species is different in terms of their susceptibility to mycotoxins. So you will see that in few slides. And our last topic is actually an important aspect of emerging mycotoxin management, which is seen or becoming a major issue, at least in Europe, as we see at this stage. A lot of research is going on in this area. So something we're going to share about our analysis. And finally, I would end up with my concluding remarks. So let's start with our approach, Travel Nutrition, Nutreco approach of our purpose is feeding the future, of course. And when we having this mission, the purpose of feeding the future, we have to maintain the food safety. And to maintain the food safety, we need to have the feed safety along the entire value chain. Starting from the raw material on the left-hand side, whether it is maize, whether it is soy meals or protein meals for that example. So maintaining the quality becomes very important, and mycotoxin levels also play a critical role there. And then you go to the commercial feed mill where you produce the feed. There again, feed processing, moisture loss, quality control in terms of microbes, mycotoxins become an important aspect. Then you move on to the integrators and home mixers. Of course, they do have their own feed mills, of a different capacity depending upon the population. So there again, feed processing, quality, microbial contamination, mycotoxin contamination has to be dealt in detail. But finally, the food production, food processors. There are two levels here. One is food production, whether it is meat, milk, or eggs, or the processing. There also mycotoxins play a role because across the world there are different regulations on the amount of mycotoxin that is allowed in the milk, meat, or eggs. Some more developments are happening in that area also. But also the second aspect is that how the food we are producing, how can we convert again back into the raw material that can be used in the feed production. So that is also a very interesting area for us because today there's so much of food wastage across the world. We need to make use of that in order to be playing a significant role in the sustainable agriculture. So in this whole area, our services helps in understanding the gap between what the expected of consumer in terms of food safety and traceability and what we are today. And of course, through our master lab, through our technical solutions, through our dosing equipments, we all try to achieve that goal. So coming to mycotoxins, as all of you know, it is not a new science. It has been around for quite some time, but every year it's evolving it. And if some of you might have been to the World Mycotoxin Forum, which is the conference for mycotoxins. New subjects are coming up every year, and this year it will be in Italy. You see a lot of new subjects are coming up, but still, as a gold standard, we do analyze the 6 different mycotoxins: deoxynivalenol, T2, zearalenol, phemonosines, aflatoxins, and ochratoxins. I call these as big 6 mycotoxins. So these are important as a markers. It doesn't mean that only they are present. And you can see I listed quite a few toxins underneath that. There are more than 600 mycotoxins that are known today, but these are just used as a marker. I am sure for a different purpose, research purpose. So if you want to understand if you look at the legal issues, or if you want to understand a bit more in detail, of course you need LCMS going forward also. For further understanding of these challenges. So, however, we have given a lot of emphasis on the rapid mycotoxin analysis because LCMS is great, HPLC is great, but that cannot be installed at the customer's place, small, medium-sized feed miller's place. So the rapid analysis becomes very important. That's why an ELISA-based method we are using. Specifically the lateral flow technology, where we can analyze the 6 mycotoxins in the raw materials and feeds, complete feeds also. Also, we can evaluate aflatoxin M1 in milk because that is an important human health consideration. So we have these analysis, the instruments set up across the world in all the continents. Then we have an internal system of connecting this data as a database, and that's where what I'm presenting today as a mycotoxin database, as a webinar. We write articles on this. Of course, we do have a Microtoxin Monitor system, which is an internal system at this stage. where our salespeople can present to the customers what kind of challenges they may be experiencing, more at a country level, not at the customer level. Whereas the Mycotoxin Advisor is more customized to a particular customer who is using this MycoMaster. So we have a different set of tools to cater to the needs of different kinds of customers. So this is an example of Microtoxin Monitor. You just select the date of the year you want to analyze. You want to look at which species of animal, which raw materials you want to analyze. You want to analyze, then immediately it will give you an idea what's the average concentration of the toxins and what is the risk. In this case for piglets, we saw a Dawn high risk, Aflatoxin low risk, whereas Zia also high risk. So you can select the species of animals to evaluate this. So this has been a tremendous tool for us. And then the Mycotoxin Advisor, as I mentioned, is a bit more customer specific. And there again, you can see an easy to understand color coding, green, yellow, red, orange, to see the kind of challenges you might come across. On the left-hand side, you can see you can select the species again. But remember, this is customer specific. This is not available for all the public. So with that, Marcel, I think a poll time, a small poll to trigger some interest about this subject.
Great. Let's go to our first poll and get some input from the audience. Here we go. Let me select it. So people are starting to enter their votes. You can only add one answer, so think carefully before you put your answer in. Going really well. I will leave it open for a few more seconds to allow most of the people to vote. Almost there. Okay, I will close the poll now and then I will share the results. Here we go, Dr. Swami. 73% thought it was both of the above.
Can you recall the question, because I can't see it?
It was, sorry, it was the question was when you cannot see it, of course. I'm sorry. While evaluating animal toxicity, which of the following feed measurements becomes critical? Is it the degree of mycotoxin contamination, the concentration, or both of the above, or none of the above? And actually, by far, most people chose both degree and concentration.
That's interesting. That's the reason why I put that question. To be honest with you, percent contamination is not really that important. To get a bigger picture of what's going on, it's good. But when it comes to the animal toxicity, it's actually the amount of toxin that is getting into the animal is more important. How many micrograms of the toxin that is getting into the system is more important than whether it is 70% contamination, 80% contamination. That's a bit more a global picture. Yeah. But for animal toxicity, it's more important in the concentration. But yeah, it can be a bit confusing. Yeah. But that's the whole idea of having this poll.
Very good. We already start to learn. Thank you so much. Okay, feel free to continue.
Okay, thank you, Mas. So moving on, I'll come to our database. This is a little bit longer stretch in terms of presentation before the next poll. So apologies for that, but I thought it's important to keep it together in a flow. You will see some of the terminologies as we go forward. Percent contamination with mycotoxin, it really means that out of 100 samples, how many samples were contaminated with aflatoxin or ochratoxin, right? And that is above LOD, which I'll explain to you a bit later. Whereas when I refer to the concentration, in parts per billion in this case is actually the how much of the toxin is present in microgram per kg of feed per kg of raw materials. That is what is very important. And when you want to have a quantitative, it has to be above the LOQ. If it is between LOQ and LOD also, we should not consider that number. It should be above the limit of quantification, because then only you are certain that that is the level of toxin that is present in the sample. Then in parts per billion, of course, all of you know, it's how many microgram per kg of feed. Just not to get confused, I only present ppb, not the parts per million. Then when I refer to grains in my presentation, it refers to all types of grains that are intact, no further processing. When I refer to grain byproducts, I mean all commodities that are originated from grains only and that have gone through some sort of processing like rice bran, wheat bran, DDG, stuff like that. Protein meals, I refer to those which has a high crude protein percent, we all know, and then they've gone through process of solvent extraction, so meals, most of them, and animal origin meals are also included here, like meat meal, some of the fish meals, some people analyze them also. And then other protein products I refer to, sometimes we use the whole peas or we use groundnut and some other which are not really extracted with using the solvent. I keep them in other protein products. You might wonder why I am doing this is because depending upon the type of the portion of those grains and proteins are represented in that particular commodity, the mycotoxin level changes. So in the byproducts is mainly a lot of fiber, you see more mycotoxins. Whereas in starchy rich, we'll have less mycotoxin. So that's why this classification is very important. Otherwise, the number may not make a lot of sense. So in terms of the data, we have close to about 32,000 data points. Number of countries were represented was 41. Raw materials was 61%. Complete feeds 39% of the data. And at least for one mycotoxin, without using the filter of limit of detection, LOD, it was 89%. But when you apply the LOD and LOQ stuff, LOD especially here, it reduced to 51%, right? So remember that sometimes the instruments can give the value with even if the value is less than the limit of detection. We should not consider that. That's why they made the limit of detection. So you see, the way we present is also very important. So it reduced to 51%, and the maximum concentration of the toxin we found was Phemonosine from Spain sample. It was 25,000 ppb or 25 ppm. On the right side, you also see in terms of the data points, most 35% of the samples were analyzed for Afla, 21% DON, 16% ZIA, and 13 Phemonosine, and lesser percentage for T2 and OTA. In some regions, actually, they should do more OTA, especially in Europe. But we are seeing the trend of not analyzing so much of OTA. In terms of the region, these are the countries. I'll not go through each one of them. In Europe, North America, LATAM, Middle East and Africa, MEA, Asia, these are the different countries that are represented. And again, maximum data has come from Europe, next North America, LATAM, MEA and Asian region. Data analysis by sample type. As I mentioned to you, 39% is actually from feeds, grains 35%, grain byproducts 10%, protein meals 5.4%, and lesser percentages of silages and other protein products, and unspecified samples are also there, which is significant, and that's why we always try to educate our customers. Please do a good naming of the sample. Otherwise, a lot of data get wasted, which is unfortunate. it could have been contributing nicely to our presentation. Sample details, I wouldn't like to go through each one of these, but you can see maize, wheat, barley being the major grains, and the byproducts of maize were the wheat bran, were the second one in terms of grain byproducts. Protein meal, soya meal, of course, is the number one, followed by sunflower and cottonseed, and some other protein products, as I mentioned to you before. Feeds, pig feed, which is including the sow and the grower finisher feed was the maximum number you saw there, followed by layers and broilers. We did have ruminant feed, that is concentrate, piglet feed, pet food, aqua feed. So these numbers are coming up more and more, and hopefully, every passing year we have more data to present. We had 2 silages also presented in this picture. So moving to the entire data analysis, that means I don't differentiate between a feed and a raw material in these few slides. And you can see the percentage of contamination for aflatoxin was 63% when I apply the LOD. Without that, could have been 91%. So the data can be misleading also. So it's important that we apply the limit of detection filter to these. T2 was 18%, ZR was 53%, OTA was 39%, DON was 48%, and Phemonosine was 44% of contamination. So again, the filter of LOD is very important. The average concentration parts per billion and the median, look at the difference between these two. And this I will emphasize quite a bit today. You see the average for aflatoxin was 12 ppb and median is only 3 ppb. So because few samples, like if for example you saw the maximum concentration of 2010 ppb of aflatoxin, which is very rare to see, but even if 4 or 5 such samples comes into the picture due to the hotspot and whatever the reason, all of a sudden your average goes up significantly. So for me, the median is the better way. So you are coming to the center of the data point. Representation is better than the average. So you see a little bit more wide is important. T2, there was a 2.9 times overestimation, ZR 2.4 times, OTA 1.9 times, DON and Phemonosine about 1.8 and 1.6. As you can see, for DON and Phemonosine, you see less overestimation. It's because these are field mycotoxins, and in the field, the hotspot creation or variability in the data is less. That's why you see between the average and the median, not a big difference. But when it goes to the aflatoxin, OTA, and T2, ZR, they can be produced in the storage also. That's why we tend to see a bigger overestimation. So moving on to the next set of slides. So you can see in the center, let's focus on the center today. And to start with, you see this is a box plot. And basically in the box plot, 5 parameters are being analyzed. You see the bottom is the the 1% percentile data representing 1%. We call 0% also. And then we have the 25 percentile, 25% of data, 50 percentile. This means this is median. Then we have the 75 percentile, and then we have the upper percentile. We call it as a 100 percentile. So this is the data. Instead of only looking at average, you have got more information here when you start doing this box plot. But box plot also has got some limitation because it doesn't show the density of the data. And it doesn't also indicate clearly the outliers. When it comes to the box and jitter plot, as you can see on the left side here, then you see the density of the data. Let us focus on aflatoxin in this case, right? You see this is the box here, and usually median will be inside this, as we explained. But you see the average in the diamond shape. This is the average number, which is moved up the box, that means there is a lot of variability in the data. Aflatoxin is highly variable from sample to sample, is just because maybe hotspot creation and different raw materials, different parts of the world. So you see a lot of variability. You look at okra, DON, and Phemonosine. Already the average came inside the box. It started getting closer to the median, which is good because the data is more reliable and less variable. And it all depends upon the nature of the toxin, also nature of the sample also. For okra, similar to aflatoxin, is not so, it's a variable, and for the same applies to T2 and Zia also. So, but the highest variability in terms of data set is for aflatoxin, followed by Zia, then T2, and then OTA, and then I think DON, and finally the Phemonosines, very clearly illustrating that the field contamination is more uniform. DON and Phemonosine are field mycotoxins as compared to the storage mycotoxins. Zia should be also, but Zia, we have seen a lot of cases growing, producing more in the storage also. So if you look at the right side, this is the percentage of contamination. As I said, this is concentration, right? ppb. This is contamination. You can see pretty much, aflatoxin, if you take all the grains, ingredients at quite a high level. If you take DON, except for, I would say, protein meals and other protein products. So protein products seems to be less susceptible for DON contamination. So the field contamination of protein meals is less. And then you have Phemonosines. Again, we expect high levels in the grains. That's common. Grain products also common, predominantly maize. But also we see in the feeds, because feeds also contain a significant amount of corn, so we tend to see high levels. Microtoxin is across, except for if you see the other protein products, we see less, but relatively lesser percentage. T2 also lesser percentage than the aflatoxin DON particularly, and Zia can be high. Because most of the time DON Zia comes together, so you can see a high percentage of contamination in terms of Zia. So when it comes to the concentration in terms of the region, as I said, MEA, Asia, LATAM, North America, Europe, you see, if you take aflatoxin, as expected, you see more levels in Asia. You see OTA again in Asia. T2 toxin, you see more in North America. And also in Europe, due to a relatively temperate, semi-temperate regions, you tend to see more of T2 issues also. If you look at FUM, as expected, you see more in Asia, hot climatic conditions, LATAM, and also Europe. Probably this is coming from the southern part of the Europe, or maybe some imported raw materials also, but I don't expect a lot to be seen in the western part of the Europe, due to the growing conditions and also less corn being produced. And DON is expected. This is a bit of an unexpected in Asia, but I can see countries like Japan, Philippines, and many countries import the raw materials from US, so it wouldn't be surprising to get those numbers also. Busy slide, but I just would like to make few points here. Basically, this is depending upon the region, how is the distribution of different toxins. Aflatoxin, you see, whether it is African region, Asian region, you still a lot of variability. Okay, you see, but the highest variability you see in South America for aflatoxin. Maybe the storage issues. So hotspot creation is much more higher in Latin America, according to the data. Okay, and you see the Ochratoxin relatively better for Asia and Africa, and again you see for Europe, variability is a bit high, and not so bad for this is for Europe, yeah. And then if you look at T2 toxin, it's better compared to other two toxins in all the regions, except maybe in North America, a bit of a variability. As you see, the average is going above the box. Inside the box is always good. And if you look at ZIA, again, variability is high for Europe, Latin America, Europe, and also for North America. So it depends on the region, depends on various storage conditions, all determine that. Look at Dawn, very nice. Everything is inside, across the globe. You see less variability in the sample. If you look at Phemonosine, the same thing. In fact, better than Dawn. So the variability is much lesser in these two toxins. When it comes to the raw materials, we have, as I said to you, grain products, and how does it shape? You see the grains, you have a lot of variability. You can see there, the average is much above the box. The same thing for the grain byproducts, relatively better for the protein meals, and you see other protein products. That means bit of an unprocessed protein products. You see much better, lesser variability. And feeds, again, bit variability is there. And yeah, you can see similarly for aflatoxin is relatively better, but T2 again is relatively better, you know, but see these two, Dawn and Phemonosine, pretty much across the region for all the raw materials, the variability is less. So we can really conclude that across the globe, when it comes to afla, variability is very high for pretty much all the raw materials, whereas for Dawn and Phemonosine, the variability is very less, and the remaining three toxins kind of stay in between. Then if you look at a particular raw material analysis, because I think it's good to analyze as a total database, but some of you may want to see what is the issue in terms of maize or other some raw materials. So if you look at, I chose maize, wheat, soybean meal, and corn silage because at least in monogastric, main wheat and soy are major ingredients, and corn silage, of course, from the point of ruminants. You see aflatoxin, you see a very high percentage of contamination for corn silage. And Dawn also is pretty much across. You see high levels of contamination in corn silage for all the toxins. And you see if maize also quite high as compared to the wheat, and that is very well known. Wheat is also susceptible, but compared to corn, wheat is less susceptible. And then if you look at soybean, is the least, except for aflatoxins, we do see that sometimes higher levels. So a bit more on the expected lines, but corn silage, a bit surprising high levels being seen. I think most of it is coming from the field before you make the corn silage. But if the silage processing is not good, maybe there is continuation of production of various mycotoxins within the silage. We're looking at different toxin concentrations. Again, this is important, concentration for animal toxicity. You see for aflatoxin, if you look at all the data, you see, I have classified these toxins into two groups, afla, OTA, and T2 as one group, Phemonosine, Dawn, and ZIA as another group, because the level of the concentration is so different between these six toxins. It's impossible to represent in one picture, and will be very difficult to actually see the numbers. You see, as expected, a bit more of aflatoxin you see in maize comparatively. OTA you see in maize again, and T2 toxin we see a bit in the maize and also wheat. Look at Phemonosine in the blue line here, dark blue. You see highest levels across all the samples, followed by Dawn. So the second is Dawn usually in terms of concentration, and then the last one is ZIA. But in corn silage, this is also going up. Remember, ZIA is even at low level can be already toxic, whereas birds can tolerate a bit higher levels, or animals can tolerate higher levels of phemonosines and Dawn. Couple of slides. This is this slide for maize. In terms of aflatoxin distribution, particularly if you're looking at maize, Again, variability is high, is outside the box. So a lot of numbers, high numbers on the top. Dawn, more uniform, as you can see, around 1,800 parts per billion or so. Phemonosine is more than 1,000 ppb. You can see around good less variability, and ochratoxin, high variability. T2 better, again ZIA is outside the box. So you can see the different toxins behave differently in maize. If you look at regions, difficult to see here. Just to give an idea, depending on the region also, there is a bit of a variation in terms of how the mycotoxin distribution takes place in these. But I'm happy to share later if anybody is interested. The complete feed analysis, for me, being a veterinarian, I think that's the most important, because that's where the problem starts. That's where you get the complaints about the feed. That's where the veterinarian goes and see the animals. Becomes crucial. And whenever there is an issue about the toxicity, it is good to go with the feed. So look at the feeds, broiler feed. Again, except for T2, pretty much you see a high level of contamination percentage. Same thing for layer feed, piglet feed, and pig feed. All behave pretty much in the same way. The ruminant feed also relatively a little higher OTA, and pet food. Again, aqua feed also, some data point is still less as compared to the other species, but you can see a nice trend of similar trend seeing across different feed types, because they are made of similar raw materials also. Because remember, ruminant feed is only a concentrate part, not really the silage part. It's not a TMR. So looking at feed type, aflatoxin, across all the feeds, you see some variability here and there, but pretty much around 10-12 p parts per billion. Looking at OTA, slightly lower than aflatoxin, and T2 somewhere between 30 to 50, 80 parts per billion. This is all average, remember, and this is in terms of the Phemonosine. You can see higher levels across all the feeds, followed by Dawn and followed by ZIA. So there's a similar pattern going around across the feeds. If you're looking at the total feeds, all the feeds together, the mycotoxin distribution is better than the raw materials. I think you can see very nicely here. So that is why when you do the mycotoxin analysis in the feeds, the reliability of the data is better as compared to analyze the raw materials. So that's why we should if there is an animal issue, you should first start with the feed, not with the raw materials. And then once you know there is a problem, you can go down and see whether it is a maize is a problem, soybean is a problem. That way you save the cost of analysis also. And poultry feeds, I divided in broiler and layer feed. You can see again, very nice, relatively better uniformity. Swine feeds, similar story, here and there, some small changes between the three types of feeds, fattening, piglet, sows, but a very similar story, same levels also. Ruminant feed, you can see there in terms of the aflatoxin, bit of a variability is there, as you can see, but for other toxins, the variability is relatively less. Showing again, aflatoxin seems to be a challenge in terms of getting a consistent or reliable number. Pet food, relatively less data, but again see nice, better than the raw materials. We don't have enough data for okra and T2. Aqua feed also we don't have enough data for ZIA, but yeah, I think over a period of time, start accruing more data, it becomes more realistic. But again, better in terms of the consistency or the repeatability of the analysis. So Mas, long stretch, but didn't have option. But here you go for another poll.
Yes, we will run another quick poll, and then maybe we can answer a few questions that came in.
Yeah, happy to do.
Okay. Let me first launch the second poll. Here we go, and let me read it out for you, Swami, so you know which question. This one is,
Yeah.
when you receive a field complaint of suspected mycotoxin issues, what should be the first sample to be considered for analysis? And then people can select one answer, which is maize, soybean meal, DDGS, or complete feed. And I see a lot of people jumped on this poll because they are voting. Really good to see.
Yeah. This is something I really, emphasize, because spending money, we should do it rationally and on these analyses. So
indeed. Yeah. So I'll just leave it open for a little bit longer, but I see a large group already voted. And in the meantime, people, if you have questions, there is a question box in the GoToWebinar menu. So feel free to type your questions there, and we will try to answer a few now, and then we can answer a few more at the end of the presentation. So feel free to keep them coming. Okay, I will go ahead and close the poll, and I will share the results. And there's a bit of a split going on, with about 2/3 of the people selecting the complete feed and 1/3 of the people selecting maize to be analyzed first.
yeah, I think it's a major raw material. I'm glad that at least they didn't pick up soybean meal or DDG. So it's a major raw material. But definitely feed is the way to go. And once you do the feed, less cost analysis. I think the most important is less variability. That's what we are seeing just now. So do the feed, and then if you see the feed is responsible for my challenges, then go back and do maize. It doesn't matter. But feed is the most reliable one to do. Yeah.
Would it then make sense, after you've analyzed your complete feed and you see there is actually a mycotoxin issue with one of the 6?
Yes.
Do you then go on to analyze the biggest component of your complete feed to kind of narrow down where the actual problem lies?
Yeah, maize should be the next one. And then of course byproducts, DDG, those kind of things, corn gluten meal, and then the soybean meal. So that should be the order. Yeah.
Yeah. A question that came in was related to the part about the global view. Some people are asking whether you have any idea why in EU there are higher levels of mycotoxins, for example, when you compare to Asia.
I mean, see, it depends on the toxins. That's what I'm saying. And if you look at aflatoxin, actually, is higher in Asian region. But in terms of DON, definitely it will be more in Europe because of the climatic conditions, growing conditions. During the growing season, you see if a lot of rainfall is there, then that year you have more DON coming in, especially during the silking time. And today it is really difficult to pinpoint by region. The reason for that is there is a lot of trading of raw materials across the world. For example, what's produced the corn in Brazil or in US, it's coming to Japan and Philippines. So that's what I am encouraging my colleagues also in the future to importance to give origin of the raw material rather than where the feed is produced. So we should know the origin of the raw material. We should mention that when you're sending the sample. That way we can enter into our system. So it gives you more information. So far, some are doing it, not all of them. So, that's why I say when you are using raw material in Africa, for example, most of the raw materials are coming from outside. So they should know the growing conditions, what kind of DON. So if you're getting raw materials from Brazil and you have a lot of Phemonosines, if you're coming from US, you have a lot of DON and things like that.
Yeah. So it's always good, I guess, to run some sort of analysis when you receive the materials as well.
Yeah.
We have more questions actually, but let's move on for now, and then we will get back to it. Actually, one question is related to what to look out for in the animal, and I think you will be touching upon that a little bit as well, right? So stay tuned.
Exactly. Yeah. Okay. Thanks, Mars. And moving ahead, so of course, being veterinarian for me is fine. The numbers are great, but what does it really mean to the animals in terms of toxicity? So, and we know that all the animals are not equally susceptible to mycotoxins. And depending upon the type of toxin you see, the number of toxins we see, the concentration we see. Yeah, I didn't mention contamination. It's a concentration, right? So the concentration of toxin, duration of exposure, how long it's exposed, presence of other toxins, the order of exposure. Sometimes you have T2 toxin exposure first, then aflatoxins. That also determines, right? So with all these, if you have, we know that dawn swine is very sensitive, susceptible, followed by dairy. Last one is poultry. Zearalenone, similar pattern, and poultry can tolerate very high levels of zearalenone. Phemonosines, swine, of course, dairy and poultry. Whereas the last three, the poultry becomes more sensitive, right? So depending on the type of toxin, type of species, the toxicity can vary a bit. Of course, there are a lot of other toxins which we don't know yet, or which we don't analyze regularly. So coming to this regulatory or the guidance values set by various authorities across the world, those numbers are usually higher than what actually can be tolerated by the animals. That is for a number of reasons. Because in some countries there is no other raw material available, so then of course they have to use the contaminated material to feed the animals, to feed the human population. So there are a lot of social, economical, cultural aspects to it. But generally considered, these guidance values are higher than what the animals can tolerate. And because there are mycotoxins, so many others which we have not taken into consideration. So the emerging mycotoxins, masked mycotoxins, unknown toxins, the synergy between all these toxins, and nutritional status of the animal, it varies from farm to farm. The management varies from farm to farm, and duration of exposure, the sequence of exposure, all this varies. Maybe at one farm, the animals are exposed to dawn first, and then T2, or then afla. So it depends on the order of exposure also. So because these are not taken into consideration in the regulatory setup, so as an animal producer, we need to be a bit more careful in terms of what we allow as acceptable levels of toxins. So I don't expect you guys to go through all these numbers, but we have these practical guidance values for various species of animals, including aquaculture, pets as well. And based on this, taking the average concentration. Let me deal first with the average, and then I go to the median in the next slide. So if we take those, the average concentrations of toxins, and then you start plotting our mycotoxin guidance values, you see that piglet feed, for example, offland OTA, they are fine. They have a kind of a low toxicity for T2, high toxicity for susceptibility for dawn and flu, and Zia was about a medium toxicity. So you can see that for various species of animals, dog food, aqua feed, corn silage, ruminant feed. So you can see that, right? The moment you go to the median, it changes. So you see more greens when you use the median. So overestimation can also be a problem. Sometimes, customer has to manage with the raw materials they have. So I strongly believe median is the way to go, so that they have more space to maneuver what they can manage. And then you see, again, just take an example of, corn silage. You see very high toxicity susceptibility for T2 Zia, because Zia is can be very toxic to the reproductive system of cows. So these kind of systems, this is for a whole global data for feeds. Just remember that I don't do this for raw materials, because raw material are not a complete feed. So this species risk should be done on the total feed. And I have an example to show. If you want to do on the raw material, you should use a formula. So let's assume that we have a poultry feed with 60% of maize, 30% of soybean, and 3% of corn gluten meal. Then you need to calculate the contribution of mycotoxins from these raw materials. If you have the analysis done, so for example, you multiply the aflatoxin value of a corn by 0.6 because it's a 60% of the diet. You same way you multiply by 0.3 with soybean because 30%, and corn gluten meal 0.03 because it's 3%, right? So when you do that, you get a broiler feed number at the bottom, assuming that there are only 3 ingredients, plant-based ingredients in the diet. So then you see the numbers. We have aflatoxin at 10 ppb, DON at 964, T2, ZIA, Phemonosine, and OTA. And you see the T2 and OTA seems to be very toxic to the broiler chickens in this case. ZIA and Fume, no problem, whereas you have a low toxicity for aflatoxin and medium toxicity for DON. Of course, when you have these 4 toxins together, the risk is even higher. And that interaction is synergy is what we reason for us to use lower level of guidance values compared to the regulatory. So just to give a little bit at the last part of the data analysis, I'm sure you all think, well, what happened, but how does it look going forward? So I took the data from October, the last quarter of 21, and with the January data, which is already available to us, we start looking. I saw a bit of a big challenge for the dairy in terms of aflatoxins, a medium toxicity for DON and Fume, and also ZIA. Poultry, the medium toxicity for 3 different toxins, low toxicity for others. Piglets, as expected, you see a very high risk for Phemonosines and ZIA, and moderate risk for DON. And then sows, you see relatively better because they can manage a bit of a mycotoxins in there. So overall, this is how it looks. I think more data has become. Hopefully, we can share the mid-year through some email contacts to you and see what's coming through. So with that, Moss, I think we have the last poll before the last session of my presentation.
Yes, we do have a last poll indeed. A lot of questions come in as well. Do you want to have them now, or shall we wait until after?
Maybe one question I can take. Yeah,
sure.
No problem.
Let me quickly roll the last poll. It's regarding the emergent mycotoxins and what are emergent mycotoxins. And again, there's only one answer you can pick here, so read carefully before you choose it. Don't worry about making a mistake, actually. We are here to learn. Votes are coming in. Even though the question is short, people are taking a bit of time to answer here. So I guess the answers are quite long, right? You need to really read it carefully.
Yeah, it's a bit of a tricky question among of all the 3, yeah.
I will leave it open for a little bit longer. Okay, I will go ahead and close and share the results. So there's a bit of a spread in the answers. Actually, most people selected all of the above. So whether it's mycotoxins that are not routinely analyzed or not regulated, or which incidence is rapidly increasing. So most people, just under half of them, chose all 3. And then followed by mycotoxins whose incidence is rapidly increasing.
Yeah, the last one is the answer, all of the above, because this is very common nowadays in Europe. I think less talked about in the rest of the world at the moment, but toxins like eniatins and steric-matocystin, fusaric acid, mycophenolic acid, these kind of emerging mycotoxins are becoming a major issue. And one of the survey in Europe has shown pretty much all the feed samples had quite a bit of high levels of eniatins and bevoracin also. So It is something they are not regulated, but more and more information is gathered through the LC-MS analysis, so that maybe in the future there will be a bit more regulations coming across those.
Yeah.
So all the above is the right answer.
Yeah. A question that came in regarding the data you were presenting, like on the individual mycotoxins. But do you think there's also a synergy between lower levels of various mycotoxins?
Of course, absolutely. I mean, that is something we are also working on developing an index. We already developed for poultry and ruminants. We're still developing for pigs. I think that the synergy, again, another reason for why the regulatory numbers are high. So I think that bar, for example, you have individual toxin at the end, we can have an index for all the toxins together. It makes the feed bit more toxic, of course, because we have the combined effect. But that's why I think, that's why I was telling you, do the analysis properly in terms of sampling, less variability, and also taking the median is a better one than the average. When you start doing all those, we can be a bit more critical. But we also know that being too critical also not good, because customers has to use that feed, right?
Yeah.
So a balance has to be kept between those two.
But it's not a matter of simply adding up the different levels and then coming to a final toxicity, right? There's more involved in that. Yeah.
More involved, and the multiplication sometimes is 1 + 1, sometimes 1 + 1 is more than 2, and I can tell you there are some toxins 1 + 1 is less than 2 also, right? So all these it's possibility.
Yeah. Okay, let's move on for now, and we will try to keep as many questions as possible for the end.
I think we have another 18 minutes or so, right, Mas?
Yeah.
Okay, great. So the last part, of course, a very practical one, in terms of mitigating the mycotoxins, is very important because for a number of reasons, binding alone is not going to be enough. We all know that it's not something new. We need to have different mode of actions coming in. Try to understand the mycotoxin toxicity, the mode of action of toxin inside the animal, so that we come up with a better alternative through innovations in biotechnology, innovation in various microbiological or molecular genetics developments, also helping us to come up with new technologies. So that is why we believe that mycotoxin binding or adsorption, what we call, is not good enough. That can reduce the bioavailability of some toxins, but for other toxins, gut wall protection, is also a way of lowering the bioavailability of toxins. If the gut wall is stronger, the tight junctions are managed well, so the toxin will come down less. And then, of course, there are many toxins. They modulate the immune system. They modulate the antioxidant system of animals. How do we come up with a new innovative technologies to improve these systems also becomes very important. So I'm a strong believer that mycotoxin binder word may be not the right word to do today. We should go to the mitigation products rather than just the binders. So in that line, of course, we know that aflatoxins we have studied for a long time, with our technology, Toxo range. Recently, we did some research on Ergotoxin Binding, and we're happy to share that we see a significant binding to different types of toxins, ergometrine and ergocrystalline, all different types of alkalides. We saw a very good binding response, again giving a bit more promise. We knew that a good quality clay can do well against ergotoxins, but just another testament to our belief. And also, as we just mentioned, the emerging mycotoxins, all of us, we discussed just now, they are neither routinely analyzed nor legislatively regulated, but the evidence of their incidence is rapidly increasing. And in that list, you can see the Fusarium toxins, fusaric acid, fusoproiferin, eniatins, bevoracin, moniliformin, calmorine, you're quite a few of them listed in Europe already. Aspergillus toxins, we have Sterimaticin and amodin. In alternaria toxins, we have 4 different toxins there. I think three toxins there, and penicillium, mycophenolic acid. We took the eniatins out as our product, as the ability to bind these toxin. Sterimaticin also we took because we know that sterimaticin is a precursor for aflatoxin, so that we can deal with it. And then we took Racofortin C. We didn't take the mycophenolic acid because Racofortin C seems to be a good marker for silage contamination with penicillium toxins. So we took that toxin and we did some binding work. You can see there for sterimaticin, eniatin B, and also for Racofortin C at 2 different pHs, because we also know that at pH 3 sometimes products can work very well against a particular toxin. At pH 6.5 it can release it back, which is not good. Sorry, at pH 3 after getting into alkaline it can release, which is not really good. So 6.5 or 6 pH is more critical, and we saw somewhere between 75 to 80, 98% binding. So emerging mycotoxins, we have to deal with it, and with the ToxoXL kind of product, we are working more research on this area. So with that, dear attendees, I would like to conclude that the analysis of close to 32,000 samples across the globe revealed 18 to 63% mycotoxin contamination. But it may look a little less for you, but remember that we had applied the LOD approach, which is very critical. And then Zia was the most contaminant for MEA and Asia, while DON, OTA, and aflatoxin were the most contaminant for North America, LATAM, and Europe. So again, why Zia in Asia? I think it's again export of raw materials. Why Zia in MEA? The export of raw materials from US and other markets, the level can go high. And same thing applies to the DON for LATAM. Maybe some parts of Brazil may be susceptible to these, and then they start importing. I believe a lot of people in Latin America, especially South Central America, they import the raw material from US quite a bit. So we can expect the DON to be seen there. So in terms of concentrations, which is for me the most important one, is DON, Fume, T2, Zia, Afla, OTA, in that order. DON being the first, Fume, T2, Zia, Afla, and OTA showed higher toxicity to various animal species in the order. That is depending on the chart I made with the median in terms of the number of greens and number of reds and oranges and yellows. So that's what's the information coming to me. And looking ahead in 2022, yes, there is a bit of a threat of the piglets, dairy cows, sows, and poultry. Of course, we need more data to coming into the pet food and aquaculture. So maybe next year we will have a little bit more strong knowledge on this area. So the emerging mycotoxins is an important topic, and I think we all should plan to do more research in this area. Finally, I gave the presentation, but there's a lot of work behind the scene from our master lab team, Ellen, for generating this. Getting this data together for analysis. So highly thankful to her. Avinash, but is the man behind some of the statistical data. So thankful to him for helping understanding a bit more distribution of the data. And of course our global feed safety team, especially Mars as the nose today, Pedro, a feed safety lead, Gwandin, a product manager, of course always supporting me in this, coming up with this information. So yeah, that's all from my side, and thank you for and for more information, of course you can visit our website troutnutrition.com, and also you can email me at swami.haladi@troutnutrition.com. With that, thank you for your time, and happy to answer questions. Again, look forward to listen to see you all again in 2023 during the same time. Of course, we have webinars in between where I can catch up with you also. Thank you.
Thank you so much, Dr. Swami, for all your explanations. Great to get a really big picture of this overview of all the data, and to kind of translate everything into practical information for the regions and for the different materials and also for the different species. And also thank you to our audience for really putting in all those questions. I think we might have too many to answer, but we have about 10 more minutes left, so please feel free to stay on and get that extra input, or enter your questions as you still might have some. Yes, Swami, a question about this emergent mycotoxins, the section that you focused on a bit on at the end. Were they always there and we just never analyzed for them, or are they really new mycotoxins that were just not present in the feed at all before?
Yeah, it's always there. I think that's the challenge, right? We have 600 mycotoxins, and so pretty much they're always present. But unfortunately, with the advances in our analysis with LC-MS, we are learning more about them. And maybe there are some new mycotoxins coming across due to the global climatic changes. New fungus is growing, and that's happening. But they're always there, and maybe some toxins also their relevance will go down going in the future. So we see more and more, less and less T2 problems seeing across the world. So it's a fungus. We are dealing with a living organism, and depending on the microclimate, macroclimate, this fungus changes its behavior. So big six may not be the big six in the future. We may have to change the big six to a different levels of toxins. So absolutely, these toxins are there. They can modify themselves to depending on the fungal exposure, and they're always there. It's just we are discovering them.
Yeah. Very interesting. And then when we move to species, we have some questions that came in specifically for some species. For example, when we talk about poultry, which are the main 3 mycotoxins out of these big 6 that should be in focus for poultry feed producers?
It's a very good question, really good question, because there are 2 aspects of it. One is the sensitivity aspect of mycotoxin. In that case, definitely T2, is the ochratoxin is the number 1, even more than aflatoxin. T2 is number 2, afla is 3, right? But the toxicity itself is not enough. You need to look at the prevalence of the toxin, right? For example, if you look at T2 and DON, T2 may be very toxic, but the occurrence is less, whereas DON is very less toxic, but the occurrence is very high. You saw in 1000+ ppb, right? So in that way, for me, afla, ochra, or T2 and DON probably should be there now because of high occurrence, not because of high toxicity, but the level of toxin is high. I think we should start building that. Phemonosine, I am not still convinced.
Okay. So even though the levels, the ppb might be low because the concentration is so high, it's still to keep in mind for DON.
Yes.
Yeah. And then moving towards the ruminant side, there are some questions related to the ruminants. Next to aflatoxin, which we all know is one to keep in mind, right, for ruminants. What are some other most dangerous or most toxins that need to stay in focus for ruminants? And also a little bit on, are there any signs that we need to look at for in the ruminants to suspect?
No, good question. I think the aflatoxin is, let me tell you, it is more controlled because of the aflatoxin amount in milk. If you look at toxicity, aflatoxin is can be less toxic than other mycotoxins, but yes, it's important from the health point of view. Other toxins to look at is definitely in some markets, T2 toxin can be a problematic to the cows, causing what I can say to the extent of ulcerations in the intestine, and also the suppression of immune system, increase in somatic cell counts. But in terms of, again, prevalence, if you start looking at DON becomes a very important toxin. because we have seen data somewhere around 400, 500 ppb itself. Already the milk production started going down in cows, and also affecting the microbial protein synthesis. We already know that. So I think Afla T2 Dawn for me seems to be the most important. Zeralanan, sorry, that is there in all the mammals. All the mammals keep Zeralanan all the time, except poultry.
Yeah.
So number 2 is Zeralanan, number 3 is Dawn, and then number 4 is probably T2, given the occurrence.
And related to this Dawn, there's a question about, it's known to be, it's difficult sometimes to bind Dawn with mycotoxin binders. Are there any solutions that go beyond binding that can still help fighting, not specifically Dawn, but maybe also other mycotoxins that are more difficult to bind?
Yeah, I mean, that's what exactly I was mentioning. We looked at Dawn binding a lot. Bentonites, we didn't see a lot of binding to that, and that's why we look at what is the effect of Dawn on the gut. What is the effect of Dawn on the intestinal immunity? That is where we are looking at, not And yes, degradation enzymes have worked out. Some research has been done on this area. But we are also looking at not necessarily on degradation, but looking at what is the impact of the toxins. Like, for example, we have seen Dawn impacting the tight junction proteins. There is a lot of research coming out in this area in the last 5-6 years. So what can we do to empower or strengthen the tight junction proteins? And we have done some research, and we have found some ingredients which are capable of helping to improve the tight junctions, so that even though Dawn is there, Dawn is not bound, getting into the intestine, but if the tight junction is strong, probably Dawn cannot enter into the bloodstream to cause the effects.
Yeah. So it's important to, next to the binding, really have that gut support there.
Yes.
In any treatment product. Yes. Let me quickly scroll through questions because we have a few more minutes to quickly squeeze in some more questions. Yes, a question that came in was, of course, you can treat raw materials or feeds with a mycotoxin solution, but would it make sense to also treat the grains before storage with, for example, organic acids to prevent mold growth? And how does that affect the presence of the mycotoxins?
Yes, of course you can do that. That is more important for storage toxins such as ochratoxin, to some extent aflatoxin. Aflatoxin, we should remember that some part of it is produced in the field also, not necessarily in the storage. So yes, afla, ochra, Zeralanan to some extent, especially in dairy cows, we see more Zeralanan being produced in the hay process, hay storage, high fiber raw material. So yes, definitely better silage management also helps in reducing the mycotoxin levels. But what is not possible by storage is those toxins that are produced already in the field. Example, Dawn, Phemonosine, some of the aflatoxin, majority of T2 toxin, majority of Zia. These are all produced in the field by the fungus before you harvest. So you can't control that by acids application.
Yeah. Okay, well, we are getting towards the end. I think also, actually, with the last question that came in, I guess you kind of already answered the question that it's important to always perhaps apply already a mycotoxin binding solution or a support solution, even when you don't have complaints about mycotoxins, right? It's because they already originate in the field, it's sometimes difficult to know, so it's important to always have that in place.
I think good question to end. I would like to summarize also, the whole reason for me, maybe some of you get confused, why there is so much variability, why should I analyze in the first place, right? The whole point here is that raw material analysis is a QC program, QC control program. Feed analysis is to address the challenges. Your feed may have a complaint from the customer, or you are an integrator. You're a dairy farmer. You have seen a problem on the farm, so that's why the feed analysis is important. Remember, because of such high variability, none of them were the median was close to the average was close to the median in none of the toxin. So that means that mycotoxin analysis itself is not enough. You need to have information coming from your managers on the farm, what kind of symptoms they're seeing. You need to do the postmortem analysis by the veterinarians. I worked with my colleague, Melchior. Sometimes we see a lot of gizzard erosion problems in chicken, liver lesions. People say that, this is because of mycotoxins. It's absolutely, we cannot say that. Sometimes it may be adenovirus, sometimes maybe some other problem, right? So definitely mycotoxin analysis along with the veterinarian postmortem lesions report plus the farm manager's observation of symptoms, all this has to be looked together. Otherwise, you will keep blaming the feed or thinking about mycotoxin. The problem is maybe a virus. Problem is maybe a simple not giving enough water on the farm, right?
Yeah.
So this has to be taken holistically, not just in isolation.
Indeed, indeed. I think very good conclusion remark, just to keep a broad eye and make sure you know what is going on. Okay, thank you very much, Dr. Swami. Thank you very much to our audience today. This concludes our webinar. We will share the recording with you in the following days, so don't worry if you were not able to follow everything into detail. You will get the recording as well. And we really look forward to welcoming you again during our webinars throughout the year. Keep an eye on our LinkedIn channel where we will announce every webinar. So I wish you all a very good day and looking forward to meeting you again. Thank you so much.
Thank you, everyone. Thanks, Moss.
Thank you. Bye-bye.
Bye.